Alright, hey guys. Sorry I couldn't be with you all day, but I didn't want you guys to get behind at all in today's class, so I went ahead and doing our next section of Chapter 2.8 notes. Since we turned in 2.4 on Friday, then there will be no soccer div for you guys to turn in today. Alright, so everything up here is going to be 2.8. I've gone ahead and posted the assignment for you guys right here on the board, so you guys can kind of see that. I will give you guys copies of that. Well, I give the substitute copies the way you guys know what's going to be happening. I'm going to start extra credit next time I see you guys, probably on Thursday. It will be the next time I see you guys. The plan is to get an exam review, and then we'll have an exam probably next Tuesday. At least that's the plan for the near future, just so you guys are aware of that. There is an exam coming up. The plan is to have a review for you guys on Thursday, the next time I see you guys. And since we're at the end of the chapter, this is chapter 2.8, since it's the end of the chapter, I figured now would be a good time to do it. Okay, so here's what we're talking about today. We're talking about solving linear inequalities, kind of a step back from when we were doing our word problems last time on 2.4, which is word problems. When I decided to jump ahead to 2.8, which is linear inequalities, a very, very, very important topic that we cover. And what I want you guys to know, okay, is several types of notation that we use. Really, the only thing, or the main thing I want you guys to get out of this is we're going to be solving equations that have what we call our inequality symbols, something y'all are familiar with. The less than, greater than symbols, equations with those things in them. Okay? And what I want you guys to get out of it is how to find a solution to that. Now, when we find a solution to a system of inequalities, it works a little bit differently. We don't just have an equal to. We have a, how the best way to put this, a set of numbers that would be a solution. Okay? Not just one number specifically, it's more like a set of numbers. So we write it as a set, and one specifically we call is interval notation. In order to figure out what sets of numbers fit our system, you have to be able to simplify it into an expression that looks something like this. X is greater than 5, or x is less than or equal to negative 7. You have to understand that. Okay? What I'm going to show you here is how to write it, what I'm looking for. Okay? Now this one obviously y'all are probably familiar with the less than, greater than symbols. This one is greater than. Okay? This x is greater than 5. Way to do that, okay, on a number line, what I'm looking for is, back in the day, I think y'all started from 0. For my purposes, I don't need that quite as much. What I do on a number line, y'all are familiar with a number line. So I want you to make a number line, put that number in the middle, put the whole number before and the whole number after, or the integer, I guess, would be better. Integer before and integer after that. And then just say, well, is it greater than 5 or less than 5? Well, think about the numbers that are greater than 5. Yes, they're 6, 7, 8, 9, 10. But you can have numbers also such as 5.5, 5.1, 5.000001, those as well. Okay? Your job is to essentially graph that set of numbers. There's not one solution to this. There are lots of numbers that are greater than 5, so you're graphing lots of numbers. But instead of putting a point for every single one of those numbers on a number line, we just draw a line. It's something y'all are probably familiar with as well. This one is the greater than. Okay, we're not going to be using the open circles or closed circles anymore. We're not going to be doing that. We're going to be using parentheses, or we call it bracket. Okay, in this case, it's going to be a parentheses. If it's greater than, we're looking at what's called a parentheses. Right about 5, basically make a parentheses facing the direction that your solutions are located in. In this case, my solutions are facing this way. Numbers are greater than 5, 6, 7, 8, 9, 10, etc. So what I do is I draw a little line. Y'all seen this before. Just draw a little line going in that direction and put a nice pretty arrow that says that's where all of my answers will be located at. Now towards the end here, this thing keeps going. There is no stop to this, so this thing keeps going until I reach a number. They can't actually reach it, but I'm approaching a number in this case, and that number, y'all are probably certain, is that number called infinity. It looks like a lazy 8 on its side. Okay, it's the number infinity. It will go, the graph will go, the number line will go all the way towards infinity. And that's what I'm looking for. There's a set of numbers from 5 to infinity that make this a true statement. That's a number line. The way it looks like as an interval notation is you just go from the smallest number to the largest number. Okay, in this case from 5, comma, infinity. That's a set of numbers that will make this a true statement. I can put any number in here, 6, 7, 8, 9, 10, 20, 2 million, 2 billion. Okay, and any of them can go in there. That's what I'm looking for. Okay, so I need two things. A number line and a set. That's what I'm looking for. The second one, x is less than or equal to negative 7. Pretty much the same thing. It's already set up, so put that number, the number before it, sorry, number in this case after it, number before it, okay, and then draw what looks like on a number line. It's less than or equal to is a little bit different, meaning it includes that specific number. But no, it says I'm going down. So in this case, I'm going in this direction. Okay? X is less than 7. Less than or equal to 7, negative 7. So I'm looking for numbers that are less than negative 7. -8, -9, -10, etc. So again, in order to facilitate me drawing what it looks like, draw a nice little arrow going this way that says all of those numbers down there are less than -7. This way is towards positive infinity. Going that way is going towards negative infinity. In order to write the set of numbers that make that a true statement, we would go from negative infinity up to, in this case, -7. Now we use something a little bit different than a parentheses. If there's an equal to, we're not going to be using a parentheses, we're going to be using a bracket. There's a parentheses instead of a bracket. I'm sorry, there's a bracket instead of a parentheses in this case. It's going in that direction. All numbers that are less than -7, we're looking to go that direction. That's what I'm looking for. Okay, so that's pretty much the gist of this. Get your equations, okay, or get my, well, I guess we'd call these inequality equations, okay. Get them in a form that looks like where you have your x, have your variable on one side, your inequality expression in the middle, and your constant on the other side, okay. A couple here I want to solve with you guys real quick, so hopefully you guys have an idea as kind of what we're looking for here, what I'm trying to get you guys to learn here, okay. All right, so here's what it says. Graph x is greater than or equal to -1, then write it in interval notation, okay. So start with -1. Hopefully you can read my handwriting from there. All right, -1. Number that's smaller than that is -2, and that's greater than that, 0. Looking at x is greater than or equal to -1, so the numbers that are greater than are going to go in that direction. So make a nice bold line going that way. Okay, my little infinity symbol there, and so all numbers -1, 0, 1, 2, 3, 4 would make that x a true statement. So here's what I would do. Bracket's going to go here. That is a bracket, by the way. Sorry about that. -1, comma, infinity, boom, chakalaka. Okay, there we go right there. All right. So that's what we're looking for. Okay, there's your graph of your number line. Okay, again, make it obvious that that is your number line right there. Okay, starting at -1, going to 0, and the arrow just keeps going. Okay. Now there are some you actually have to solve. Okay, pretending they're actual equations here. Okay. What I would do is if you have trouble with the inequality, if you don't like the inequality sign, pretend it's an equal sign and just solve it like we did when we were solving equations. This is pretty simple. X plus 4 is less than or equal to -6. Set it up. X plus 4 is less than or equal to -6. -4, -4. From both sides, your x is less than -10. That's what we're looking for. So there's your inequality. X is less than -10. Okay, well, draw your number line. -10, -9, -11. Okay? And since it's less than -10, so less than goes that direction. So we're going to make less than go this direction right here. Okay? That's less than. That's what we're looking for. Less than goes that way. Okay? Now, that's towards negative infinity, so your solution as a inequality set, as an interval notation, sorry, it goes from negative infinity all the way to the number -10, and it stops there. All of these numbers between negative infinity and -10 make this a true statement. Kind of what looks like what we're doing here, okay? All right. Let me skip ahead to number 4. Okay, I'll come back to number 3. All right, number 4, you have 2x is less than -4. So, it's 2 times x. The rules are the same. Pretend that's an equal sign. 2 divided by 2. X in this case is less than -2. Okay? Process is like this. All right? -2, -3, -1. Okay? It's less than, so I'm going to put a parentheses, not a bracket. Make an arrow going this way, towards negative infinity. Okay? So in this case, and then you just draw your solution. Negative infinity, -2, etc., etc. All right? So example 3. -2x less than or equal to -4. All right? Divide by -2. Now, one of the special rules is when you divide by -2, what you're going to do is you're going to, when you divide by a negative, the rule is you probably learned it back in Algebra 1, is to, if you divide an inequality by a negative, it flips the inequality sign. So instead of being less than or equal to, this one's going to be greater than or equal to. So the special rules, and you only change it though. Some people like to just flip it just because. The only time you change it is when you're dividing by a negative. Please only do it when you're dividing by a negative. Don't mess that up. Those will cancel out. I'm getting x is greater than or equal to, in this case, 2. It's a 2, so again, 2, 1, 3. It's greater than or equal to, make a nice pretty bracket going in that direction. Towards infinity, your inequality, your set is going to be 2 and infinity, just like that. Okay? So we're looking for. So all these have something in common, okay? Number line what we're looking for, okay? And your inequality set we're looking for. All right, last 2 over here, all right? I've got one where it's an actual equation. So we'll start 2 expressions on either side, okay? Slightly more complicated than those, but not impossible to do. 2x plus 7 is less than or equal to x minus 11. So solve it, pretend there's an equal sign. Okay? That's all you have to do. Pretend that there's an equal sign there, and then just solve it. I try to keep x's positive when I can. That's just my own thing. If you want to do it differently, that's fine. I'm going to try to keep x positive if I can, okay? So I'm going to move this x from this side to this side, first thing, okay? Draw my little t in the middle, okay? So make sure that I'm not going to cross it, you know, make sure I'm not going to cross anything here, right? I move my x's to this side, I'll move my 7 to that side, and then combine like terms. Those will cancel, those will cancel. 2 minus 1x is 1x. My sign stays the same. I get x combine negative 11, negative 7, get negative 18. There's your inequality, right? And just put it on a number line. Got negative 18, negative 17, negative 19. It's going to the left. One thing that you can notice actually, if you put the x first or your variable first, the inequality symbol will actually show you the way you're going, but don't use that as the main marker. Just make sure you note that, well, it's less than, going that way. X is less than 18, so I got to go, and it's equal to, like a nice pretty bracket, go in that direction. There's a nice pretty bracket, it goes that way. Okay? And then again, write your interval. Okay? That way towards negative infinity. You always write the smaller number first. I'm going from negative infinity all the way up to negative 18. Okay? That's why I put this one first. So you notice how this one has an infinity here and that one has an infinity there. Whichever number is smaller goes first. In this case, negative infinity is smaller and then negative 2. In this case, 2 is the smaller number and infinity is the bigger number. Put them in the order from smallest to largest. Okay, smaller number comes first. That's how we read numbers from left to right. Okay, on a graph, on a number line. Okay, smaller numbers are this way, larger numbers are this way. Not necessarily quantities, but actual values of themselves. Okay. All right, last one. Okay, last one. You might see an example that has 2 inequality symbols in it. In this case, I've got a less than or equal to and a less than symbol. Okay, if you have an instance like that, what you're going to do, okay, is pretend there are 2 equations here. There's one equation here. There's one equation right there. If that happens, treat it as if you're doing them both at the same time. First I'm going to do in this one, I would add 3 here. First I'm going to do in that one would be to add 3 also. So I'm going to add 3 here, and I add 3 here also. There are 2 of them that you're going to add 3 to. Okay, in this case I'm going to add 3 to all of them. In this case, x is going to be between, if my main equation is between 2 numbers, x is going to be between 2 values. It has to fit 2 parameters here. In this case, I would have a 2, less than or equal to 2x is less than 8. Alright, so that's what I've done. Add 3 on both sides, 3 in the middle cancels, and I'm left with an x in the middle. Not quite done, because I've got to get rid of that 2, and y'all know, if we have to get rid of that 2, it's 2 times x, so I've got to divide by 2. 2 over 2 is 1, less than or equal to, those 2 go away, and less than 4. So there you go. This means that x has to be greater than or equal to this one, or x has got to be less than that one. It's got to be both of those, essentially. It's like an and statement. It has to be bigger than one, but less than the other one. Well, the only